we'll do this.
Woohoo! Oh my God.
Kind of neat, huh?
Pretty much.
Technology. I've read about it.
Yeah, it's a myth. It's not a thing. It's not a
it's a fad, just like Azure.
Who is this Azure everyone is talking about?
Yeah. I know. It's like everybody refers to the market, but I have yet to meet the market. And if I did meet the market, I would probably punch them in the face. But that's me. And that is not
Overheard.
according to the code
I
of
will
conduct, by
punch
the
the
way.
market in the face. That totally should go into your Twitter bio.
I'm pretty sure that there'd be a lot of people lining up to do the same. But again, that is not technically according to the code of conduct.
True. And I mean, how horrible would it be if I had to kick you off the session because of a code of conduct breach? I mean,
we've had this discussion before about the idea of needing to kick speakers out during it would be, I think people would talk.
let's leave it at that. It should be
Yes.
done before the session because in most cases you should know before if I'm saying in most cases, maybe not for newcomers, but otherwise you should be aware if a speaker means trouble. And having that said, it is 7:30 UTC. I will disable my video and mute myself. Alexander, take it away. Everyone, please enjoy the first session of the day here at the DBA track at GroupBy Europe.
Thank you for that one. And thank you so much for everybody attending. And I mean, at first it's early in the morning, well, 9:30 here in Sweden, but UTC it's 7:30, and that is very, very early. For once, I'm only fighting against one person because we're just doing 2 tracks here. But again, thank you so much for attending this session and not going off to the other session. This is called Not My Problem. And so this is a normal, this is a pretty common misconception. Is it my problem? Is it not my problem? Well, as we're going to see, I'm pretty sure it'll turn into your problem. So first, again, thank you for attending and welcome to GroupBy. GroupBy is a fantastic idea. It was started by Brent Ozar a couple of years back, and now it's pretty much gotten a life of its own. I think it was handed to Daniel Ottmacher for safekeeping, and he's doing the organizing most of the organization. And as always, we have amazing people doing volunteering, such as Ben and Rob. And I'm pretty sure that Rob is thinking of legally changing his name to Beardy McBeardface. I would support that. So this is fantastic free online training, free as in completely free, by the community, for the community. And I'm so happy to be part of this. I've been speaking for quite some time, and what we generally do is that we send out submissions for conferences, and then the conference organizers pick, or in some cases do not pick you. The GroupBy is way harder to get into because we're a lot of people sending in submissions, but it's the community that actually decides on who gets to speak at GroupBy. So that's why I cherish GroupBy very, very much. And as Ben said, we have the GroupBy code of conduct, or the general code of conduct. And this is not just boilerplate. This is one of the most important slides in any session. I cannot state that highly enough. So please read this and abide by this. I'm sure we're not going to have an issue, but it's here for a reason. Let's leave it at that. So we all have them. You know, the friends that mean so well, but constantly manage to screw the most basic of tasks up. One of my friends is like that. Not because he's being stupid. No. But just because he doesn't always have the whole picture before he runs off to do something. He called me one morning some time ago and to excitedly explain that his company had assigned him to a team that was looking at moving database workloads to the cloud. But he's been an on-prem DBA for quite some time, and he felt that he needed to get up to speed on the cloud in general. And he had started to realize that maybe, just maybe, he was the most experienced guy in the project. Let's just say that his networking skills were limited. His call and the discussions we subsequently had sparked this session. And he'll be figuring in here from time to time, but I've redacted the names of the guilty for the sake of all involved. I think that is a good thing for my future friendship with the guy. But before we go any further, I would like to extend my heartfelt thank you to all of our sponsors. Just like the code of conduct is important, this is also extremely important. We all know sponsor slides and just go, yeah, meh, and move on. Look at these sponsors, visit these sponsors, because without the sponsors, we couldn't have this. And this is even more important on for an on-prem event. But keep in mind that it is not free to create a virtual event at all. So sponsors, we love you. Thank you for helping out, really. And of course, thank you for the amazing volunteers, always. So this is pretty much the way that we are used to look at SQL Server, all alone at the center of the universe. And if you talk to DBA, they're more than happy to talk about their database, but rarely do they want to think about icky stuff like storage or servers or virtualization, or God forbid, networking. The problem with this thinking is that the cloud not only brings with it new opportunities, but it also brings with it new architecture and, even more importantly, new divisions of labor. You see, everyone wants to do more with less. That we can agree with. And while reuse and automation and integration can all be used to good effect to save money, so can what's known as changing the scope of practice. The scope of practice is a medical term, but I'll explain what I mean with that as we go along. Because people, they used to do one thing and one thing only, very, very well, I might add. But they might find themselves in a world where they are expected to do more. They may not necessarily need to know a lot about the different areas, but they sure do need to know something. So we are going to look at a few things. And I mean, it basically brings us to this session. It is called Networking 101 for a reason. We'll be covering the basics of networking in Azure, what it is, how it behaves, what it does not do, basically. We're going to look at the huge Lego brick set that is networking in Azure and in Azure in general, because there are so many bits and pieces. And as with any Lego set, you can get pieces to fit using enough glue and or violence. But yeah, and ask me how I know. That is not the way you should build things. So we're going to look at why some bits and pieces go together and why some pieces might not. And of course, we're going to pick up some tips along the way. There are some smart ways of doing things, and there are some less smart ways of doing things. And as always, one of the most interesting and equally frustrating things with speaking and working with these things is that if you turn your back on something, it'll change, which one thing has. And I'm going to cover that as we go along. So if we lift our eyes from the database-centric view, I know it's a terrible thing to do, but let's, for the sake of the argument, lift our eyes from the database-centric view. We can see that the database is just a small part of a bigger environment. Why? Well, it's kind of obvious when you think of it. Databases does not have any value in it in their own. Just like IT have no value unless it is supporting a business. There's no point in having an IT organization if you're not actively supporting the business. And traditionally, all this stuff has been handled by the others. But in Azure, I find that a lot of times the others, they turn into you. My goal today is to give you a good understanding of the building blocks in networking in Azure, at least enough to help you figure out the right questions to ask to move forward. There are a couple of ways of doing training and doing speaking in my view sessions. One is to go through the technical details. I generally don't do that because that is more a how kind of session and how kind of discussion. I'm more focused on the concepts. Why would you do this? And what would you use in order to accomplish something? That is a heck of a lot harder to Google. I can Google the specific settings for a load balancer or how to configure a specific part of SQL Server, fine. But I cannot Google why or how I would architect a networking solution in the same easy way that I would do a specific setting. So that's where I'm going with this session. My name is Alexander. I have 24 or 25 years in IT, pretty much all of it spent with databases, data infrastructure in some way, shape, or form. These days, I work for Solution Experts in Sweden, a small outfit. We're 33 people. And I'm a principal solutions architect, which is, by the way, the best title I've ever had because nobody knows what I do. But that's pretty easy to explain because I make data matter, because only data that matters can inspire any change. And I do this, or I should say I used to do this by going all over the world, speaking at conferences, teaching courses, and doing consulting. But since March of last year, when the world basically ended, I've been stuck in my home office. It's a nice home office. That's fine. But I'm terribly tired of this home office. Then again, everybody else is stuck in it. So, well, not necessarily this specific home office, but I think you get the gist. When it comes to making data matter and making things matter, I just took on a new role at work. I'm now also a chief innovation officer, which is an even better title, I think. So now I'm working with making people understand data just as well as making data matter. A lot of fun. I'm one of 7 data platform MVPs, or most valuable professionals in Sweden. I'm a certified trainer. I co-host a podcast called Media Tech. And yes, if you're my age or older, you're probably recognizing the Do game logo. Might just be one of the best games ever. Not that Ben Weisman wouldn't know. Exactly. So let's start with something we're fairly familiar with. SQL Server on a virtual machine. In this specific case, however, the virtual machine is not on-prem. It's in Azure. Well, the cloud is just somebody else's data center, I've been told over and over again. And in some respects, yeah, sure, that is true. There's just so much more to it than just that. But for the sake of this discussion, let's agree that's the case and look at the similarities with working on-prem as opposed to working in Azure. And just like on-prem, the database does not live in a vacuum. It lives in something. And this something is in a network of some sort. The network is used for many things, enabling connections to other components. I mean, it would be kind of hard to make a multi-component solution without interconnections, right? It is used for securing access and making sure that only the relevant and allowed traffic flows in and around the components, pretty much. We're going to take a look in the portal a quickie to see what we can see on a virtual machine. It looks just about like any virtual machine you've seen back home, and we can see, for instance, that we have the public IP address. Unfortunately, let me zoom a bit. Unfortunately, Zoomit doesn't work very well with the setup that I have when we're doing online stuff. But I found a kind of a workaround that I can use screen snipping to just mark. So it's better. Not great, but it's better. Kind of like they say in Chernobyl, not good, not terrible, not great. So we have the public IP address. We can also see the public IP address over here, but we also see which network, and in this case also in which subnet. I'm going to come back to all these things in a bit. This specific virtual machine is running in. But we also have down here, and this one is kind of important, the private IP address. So it turns out that we have a private IP address, and we have, or we might have, a public IP address. Some of you know exactly what I'm talking about. Some of you are scratching your heads. That's fine. I'm going to unscratch that for you in a bit. That was a weird sentence, but I'll take it. So this is pretty much a normal virtual machine, just like you're running at home. The good thing with Azure is that you have a great, it's very easy to create it, as you know, and it's easy to manage inside of the portal. So again, the virtual network is the fundamental building block for your private network in Azure. VNets, they enable many types of Azure resources, like Azure virtual machines, like we just saw, to communicate securely with each other, the internet, and if you have designed it that way, your on-prem networks. A VNet is very similar to a traditional network that you'd operate in your own data center, but it brings with it some additional benefits of the Azure infrastructure, such as scale, availability, and isolation. Now, the funny thing is, and this tends to confuse some people, all the resources in a virtual network can communicate outbound to the internet by default. Yep, this is the case. You can communicate inbound to a resource inside of a virtual network by assigning a public IP address or a public load balancer. I'm going to get to the load balancer in a bit as well. So hence, in order to get in to anything, you need a public IP address for that specific resource. My wife is a teacher. She's the smart one in this family because she has 3 degrees. I have none. But one of the degrees she has is in microbiology. And she has been teaching high school students, and she has been teaching people that are becoming high school teachers. And one of the things that she says is that, well, there's this concept of lies to children, which is when you explain something in an easy to understand manner, but you're not necessarily explaining the entire truth. And that's exactly what I'm going to stick with here. The fact that anything that you want to talk to needs a public IP address, well, it's kind of lies to children, but just leave it at that. We're going to need this simplification for the moment. So how can you access your resources from on-prem? Well, you can set up what's known as a virtual private network. In this case, we are having 2 endpoints, one in our on-prem network and one in Azure. And between them, we have what's known as a tunnel, a VPN tunnel. And the traffic goes over the internet, but it is very much encrypted, basically up to the gills. So this is a way to, in many respects, connect my on-prem network to my Azure network, and everything behaves like it is the same network. I can talk to the different resources just as if they were on-prem. But we generally don't have just one network. We don't have one network or one subnet at home. I'm pretty sure we're not going to have the same thing in Azure either. Because we're going to have several other networks, but from a connectivity perspective, they might just as well be on the far side of the moon because traffic can't flow between the networks unless we enable it. And that is called peering. The funny thing is, as I said, traffic can flow out of the VNet and into the internet by default. All resources in a virtual network can communicate outbound to the internet by default. All right, so peering. What is peering? Well, by peering the networks together, we're basically joining them at the hip. You can look at it as if you're joining two tables together in the database. One huge caveat is that peering relationships are not transitive. And that means that if I want to talk to VNet 3 over there from VNet 4, I won't be able to do so with this setup. I know that I can talk to VNet 2 and VNet 2 can talk to VNet 3, but it doesn't matter. The peering relationship is not transitive. I cannot go through VNet 2 in order to get to VNet 3. So how do I solve this? Well, easy. I can create a peering relationship between 4 and 3. Easy peasy. Now, this is not generally the way we design things. There's a smarter, simpler way, and that is the hub and spoke design. Because if I have some resources that I need to share, say for instance, the VPN gateway, the portal, if you will, between your on-prem network and Azure, I probably want to put that in the middle here. So in that case, I'm turning the VNet 3 into what's known as the hub, and the other ones turn into spoke. This is not unlike a star schema, really, because you can view the hub network as the fact table and the spoke networks as dimensions, basically. All right, and the idea is the same: reuse and simplicity. But the networks in themselves, they're almost always subdivided into subnets. And I say almost always because if you do this through the portal, you used to get a default subnet regardless of what you did. That is no longer the case, and especially if you do this through ARM or Bicep or PowerShell, you can pretty much play with this to your heart's content. But most of the time, you're going to find that there is one default subnet in a network. Now, you can do more with this. You can carve out multiple subnets from the same network. As you can see here, we have a network that is carved into subnet 1, 2, and, well, depending on the size of the subnets, you can have multiple. Traffic can flow between the subnets. Remember, you cannot go between VNets. That requires a peering. But between the subnets inside of a VNet, just go for it. It's open season, basically. My friend looked at me with a very blank face and said, dude, subnetting? It was a long time since I heard that. Could you give me a very, very quick refresher? And I said, sure, I can do that, but that's a bit difficult. So I'll go through it very, very quickly. Here we go. So look at it this way. We have one address space, in this case, one network, 200.100.10.0/24. /24 is a way of noting how many bits are reserved for the network name and how many bits for the number of hosts in the network. A /24 gives you technically 256 addresses. In Azure, it's going to be 251, but that's details. I can, using a normal table saw, basically cut that into half. And that is going to turn them into 25 networks. And it's going to give me two 25s. So two 25s and 124. And each 25 now has 128 addresses. And I can keep going. So this is a way to subdivide a network into smaller, manageable chunks. Why would I want to do this? Well, if I want to create this, a web tier where I have all the web servers. I have an application tier where I have all the application servers, and a data tier where I have the database servers. Why would I want to do this? Because it's open season. This means that I can easily talk to the database server from the web server. And I definitely don't want to do that. That is a horrible idea from a security perspective. Why would I want to subnet? Well, I want to have subnets, but I also want to have a way of blocking the traffic between the subnets that shouldn't talk to each other. I mean, the web tier should be able to talk to the application tier. The application tier should be able to talk to the database tier, but the web tier should not be able to talk to the database tier. So how the heck do we sort this? Well, say hello to network security groups. A network security group can be used to filter network traffic to and from Azure resources inside of an Azure virtual network. A network security group, it contains security rules that allow or deny inbound network or outbound network traffic from several types of Azure resources. For each rule, you can specify a source, a destination, a port, and a protocol. So you can specifically block TCP traffic on 1433, which is SQL Server, for instance. So how do we do this? What does it look like? Well, we're going to go over to the portal again and take a look at my NSG or my network security group. As a good chef, I've already set up my my NSG here. And for starters, what kind of sticks out is that we have the inbound security rules, and below that we have the outbound security rules. We're also going to see that these are hitting any and any. So any protocol, any port is going to be allowed inbound, but we're also going to be hitting a deny all inbound lastly. So the priority is the order of which these rules will be applied. But the thing with this one is we don't have it associated with anything. So this is just lying in space. It's not going to do squat. In order to use this, I would need to associate it to a subnet. And basically just click associate. I specify which subnet I want to have. And boom, that's how you do it. Not going to do that because I'll break my demo environment. That's not a good thing to do. So using the NSGs, we can implement traffic filtering in and out of the subnets. Easy peasy. This is the way you want to do things. My friend was excited. He felt that he had finally started to get to grips with this networking stuff in Azure, and he had, well, the things he'd learned had already kind of kept him from messing some security stuff up. He shot off singing something about networks and data and earning an inordinate amount of money. But he was back the next day, somewhat deflated, because he desperately wanted to talk about high availability for SQL Server on VMs in Azure, and he couldn't quite figure out the networking aspect of things. Now, I don't blame him, because this does become a tad confusing. And as the story goes, you ain't seen nothing yet. So picture your garden variety always on availability group, and we need to have a conversation with Microsoft Marketing about that name, always on availability group. Say that 10 times quickly. In this case, it consists of two servers. They are constantly talking to each other in order to stay in sync. And since either of the servers can be active at any given time, we need some way of figuring out who is basically the boss at any given moment. And of course, we know how to solve this because that's known as the listener. The listener is an artifact handled by the underlying Windows cluster if we're running on-prem. But the thing is, in this case, the cluster in Windows, which we have on these virtual machines, it can't interface with the rest of Azure. So instead, we're going to have to hang the virtual network name that we are using to talk to this pair of SQL servers. We need to hang that on something else. And depending on the version of SQL Server, we have one of two ways of doing this. We're going to start by looking at SQL Server up until 2019 cumulative update 8. And it is time, ladies and gentlemen, to introduce the load balancer. So the load balancer operates at layer 4. Well, technically it's on layer 3 and 4 of the Open Systems Interconnection, or the OSI model. It is the single point of contact for clients, can come from inside or outside of Azure. And the load balancer basically distributes inbound flows that arrive at the front end of the load balancer to the backend pools of the load balancer. So it takes traffic coming in and distributes it to what's behind it. It can be virtual machines, or it can be scale sets, or basically anything of the kind. This is done through what's known as rules, load balancing rules. Is it round robin? Is it by priority, or for instance? And also using health probes. And health probes are not unlike this annoying little brother that basically goes, are you awake yet? Are you awake yet? Are you awake yet? Are you awake yet? Over and over and over and over again. That's exactly what it does. It keeps pinging the backend to make sure that it is in fact alive and should stay on, well, in circulation pretty much. That is also one of the reasons why a load balancer works very well, but it's also going to hurt you a bit when we move on to look at how this works technically. So wait a second, what? OSI model? Layer 4? What? Take it easy. I'll walk you through it. So the OSI model, or the Open Systems Interconnect layers, then, just a minute. We have layers 1 through 7. And the further down we go, the closer we get to the electrical signals, or lights in the case of the fibers. And the further up we go, we're going to know much more about the content of the data traffic. So if I'm working at layer 3 and 4, this basically means that I'm FedEx. I have a package. I know where it came from. I know where it's going, but I don't know what it contains. I don't have a clue. And frankly, I don't care either. There is a saying in Sweden that it's something as sure as a package in the post. And back in the old days, the Swedish post office would pretty much go to any length to get a package delivered. These days, not so much. And I'm pretty sure that it's the same with FedEx. We want things to get where they're supposed to go, and sometimes they do. Anyway, in this case, they just about always do get to their position. But again, we don't know what's inside of the package. So we can't do anything to simplify traffic as it comes along. If we were to move around at layer 7, for instance, then we knew exactly what's inside of this package. For instance, I know that it's a SQL Server packet. That means that I can treat it in a specific way. Now, again, we're at layer 4 and layer 3. We don't know this. But what we can do is that we can set up this load balancer. So it is providing connections. It can provide an outbound connection for virtual machines, and it can also provide an inbound connection. There are two kinds of load balancers. We have the public, which, as you might surmise, is public facing to the rest of the internet. And we have a private load balancer, which is on the inside. So in this example, we have a public load balancer bound to TCP port 80, which is normal web traffic. It is going to hit the load balancer, and the load balancer is going to send the specific traffic to one of 3 virtual machines running a web server. Perfectamundo. The web servers do not have any public IPs. They are not exposed to the internet. It is only the load balancer which is exposed to the internet. So it's basically a gatekeeper in this case. And behind this, behind the virtual machines, we also have a load balancer to the application servers. And in this case, it works exactly the same. The application, the web servers, they talk to one IP, one address, and that address in turn gets, the traffic gets routed to one of, in this case, 3 virtual machines. The only difference between a public and a private load balancer is basically if you have a public IP or not. So it's public facing, it's a public load balancer. If it is not a public facing load balancer, it is a private load balancer. And again, as I said, we need to set a couple of things. We need to set the IP, the address. We need to set up the backend pool. In this case, we have one pool with web servers and one pool with application servers. We need to have the probe, which again is the are you awake yet, or are you dead yet, are you dead yet? And of course, we have the rules. Do we want to set this up for priority routing? We should always go to this guy first, and then if he's not available, we're going to go for this one. Or should it be round robin? All this is set on the load balancer. So let's take a peek at the load balancer, shall we? I'm pretty sure that I had one here a moment ago. Load balancer. One of the quirks with the portal is that if you zoom in enough, this part is going to stay the same size, and this, which is the interesting part, is going to get smaller. So I can't scroll in it unless I zoom out again. Here we go. We have the load balancer LB Playground 1. So what do we have? Well, absolutely nothing. This is also a load balancer, basically hanging space. It is not associated to anything. In order to set up these things, I would go for the front-end IP configuration. This one has already a public-facing IP, so that's sorted. This is a public IP address that anyone and their cat can access. But I don't have any backend pools, but I could easily add something to this connected to a specific virtual network. Now, I'm not going to find any virtual machines here because the virtual machine that I have in my network already has a public IP address, and thus it's not eligible for setting up behind a load balancer. But this is how you'd set up the backend pool. And of course, when you're done with that, you can keep going with the rules and the probes and so on and so forth. So back to the question of SQL Server then. The load balancer will do the same thing as the listener does on-prem, like we're used to having the listener as a virtual network name in our on-prem environment. The whole idea is to automatically keep track of which SQL Server is the active one in the AAG pair, right? And it's pretty much taking the traffic and routing it to the right part. If, however, we're working with 2019 cumulative update 8 or above, we could put in something else. That is known as a DNN, or a distributed network name. This does away with the load balancer, and it behaves very, very much like an always-on availability group listener in a multi-subnet failover environment would. So instead of the load balancer keeping track of the IPs in the pool, they're going to be stored in DNS. Why would you do this? Well, the simple answer is, well, Microsoft says you should. From 2019 CU8 and above, it is the recommended way of doing things. Well, and the reason for that is it's pretty easy to understand. You have fewer moving parts. You don't have a load balancer that you need to set up, you need to maintain, and you need to pay for. it is going to be faster for failover times because you're not going to be looking at the probe timeouts. And that brings us back to the probes. We have a timeout for a probe, and we also have a rule of the number of timeouts that the probe needs to hit before it decides that the backend resource is not available anymore and removes it from the routing list. So that means that you might potentially be looking at upwards of 30 seconds before the load balancer realizes that your primary SQL server is no longer serving connections. That is a long, long time. With a distributed network name, it's going to be faster. And also, up until the day before yesterday, there was no multi-region support for load balancers, which meant that if you had your SQL servers in different regions for availability reasons, you were kind of out of luck anyway, because your load balancer was tied to a specific single region. There is now, as of the day before yesterday, a way to preview a load balancer that is multi-region. So suddenly you can basically choose which one you go for. I would prefer the DNN, but be aware that the DNN needs to be set up through PowerShell. You can't do that through the portal just yet. So this is what it looks like. We now have a network that's is contained with 3 subnets. We have the web tier subnet, we have the database tier, the application tier subnet, and the database subnet. And the database tier subnet has 2 virtual machines with always on availability group, SQL Server, and a load balancer. Perfect. A word of warning, this is a bit of a tip. And I could say, ask me how I know, but I'm not going to say that. So when building something like this, always, I'll say that again, always put the virtual machines in what's known as an availability set. An availability set is a way to explain to the Azure backend that these 2 machines, or multiple machines, but these 2 are part of the same availability solution. So please do not shut them both down for maintenance at the same time. Ask me how I know. Anyways, moving on. So what about a cloud witness or a connection to a storage account? This is where it gets a bit complicated. Those resources are outside of the virtual network, despite being a part of the same resource group in Azure. Confused yet? All right, let me show you what I mean with this. So we have the resources inside of my resource group. For instance, we have a SQL database over there. We have my virtual machines over there. But I could also put in a storage account in here. In fact, I don't think I have one. Yeah, I do. I have a storage account here. The storage account is a service, but still it is inside of my my resource group. So yeah, it's going to be my personal private resource, right? Well, funny you should say that, because the resources in my resource group are not quite private per se. And I'm pretty sure my friend will have questions right about now. He was more confused than ever. As if it wasn't quite enough to be told that the resources might not be quite as private as he thought, he also wanted to talk about Azure Platform as a Service services, such as Azure SQL Server or storage accounts, because he had heard that all the traffic was routed over the internet so anyone could read it. I explained that yes, by default, the services are routed, or the traffic for the services are routed over the public internet. But remember how it works with the VPNs? Yeah, again, everything is encrypted like crazy. So don't worry about it. But how does the whole thing work? He asked. Could you just lay it out so I can figure out what's the best solution for me, please? Yeah, sure thing. Let's dive in and get your thinking caps on, because this is where it becomes a bit confusing for starters. So let's backtrack. This is the picture that I showed you earlier. Previously, we wanted to talk to a resource that was private to your virtual network inside of Azure. Right. That required the use of a VPN, or a virtual private network, to get into said network from our on-prem network. But going to the platform services, things become a tad different, because the service is openly available on the internet using something called an endpoint. Don't worry, I'll explain that in a second. And this endpoint, it looks like this. This is my, let's see where it went, SQL database. And this SQL database has a public endpoint. This is technically available for anyone to see. But again, we're talking to this service over the internet. The transport is encrypted and thus secure. The server app or whatever used to connect to the platform as a service, in this case, an Azure SQL Server, is connected through the PaaS, or the platform as a service public endpoint. Does this change if we're connecting to the service through our Azure services or Azure resources instead of our on-premises network? No, not really. And it all comes down to where the resources are placed in relation to the network we're coming from. Let's look at what endpoints are and how they relate to this specific scenario. In the case of a virtual machine in a virtual network in Azure, it probably, as I told you in the beginning, it's going to have just one private internal IP. Remember that my virtual machine in the demo has a public IP address, but I've assigned that. So by default, it's not going to have a public IP address. But also remember that I said that anything basically inside of a virtual network can talk out to the internet. And that means, by definition, TCP/IP, that a public IP address is in play as well. And this is where the whole lies to children comes in play. So I haven't assigned a virtual machine a specific public IP address, but Azure has. Azure has given it a randomly assigned IP address from a pool that Azure has, but it is not associated to an endpoint, which means that I can establish a connection from this virtual machine to something outside of it, but I cannot do it the other way around, because I don't know what IP address it has, and there is nothing talking to me at the other end. There's no public endpoint. I cannot talk to it. So this, again, this IP is only for facilitating outbound communication. Again, it does not have a public endpoint, so I can talk into it. But what if I want to talk to it? What if I want to have that specific virtual machine available from the internet? What in that case? What I need to do is assign a public IP, just like my virtual machine in the demo. There is now suddenly a very public endpoint available to the internet. It's available from the internet and pointing to this specific virtual machine. To be very, very clear, this can be a horribly bad idea. You definitely want to set a firewall on this machine at least, because I think somewhere around the 3 or 4 minutes before someone decides to try to hack your your unprotected virtual machine. That's the time you have before somebody notices. There's so much crap on the internet of always hammering everything, and especially the cloud environment. So it can be a terrible idea to just set up a virtual machine and open it up to the internet. Okay, but that's the virtual machine. What about the services? The service, again, is outside of your virtual network. So in order to talk to it, we must talk to the public endpoint of that specific service. But in this case, we have a storage account provisioned, and that storage account is accessible from a public endpoint. Okay, but what if we want to connect a completely private virtual machine? It doesn't have a public endpoint. It doesn't have a public IP. It doesn't have public anything. It's completely private. I want to connect that to a storage account. How does that work? Well, it works the same way as before, because in this case, an automatically assigned IP address will come into play with that virtual machine. And that is used to talk to the service endpoint, the public endpoint of the storage account. And with this automatically generated public IP address, we can access the storage account to our heart's content. Do note, though, again, for the 15th time, this is not a public IP with its own endpoint. It is only a public IP for the sake of being able to route traffic to and from the platform as a service, in this case, the storage account. And this is where it gets a bit weird, because the service isn't technically housed in our subscription either. It's conceptually created in your subscription, and as you could see in my resource group, it was there. But the service lives outside of any specific subscription. This is because of what's known as the billing boundary. The billing boundary in this case is the subscription, i.e., you pay for what's in your subscription, but the service providing the resource that you're paying for may not be private to your subscription. Are you confused yet? Don't worry, it'll get worse. So think about it. The storage account service, the engine, is public, but your instance, your specific storage account of that service, well, it's only available to someone with the right credentials, which would hopefully be you. As the source IP of the virtual machine will be automatically assigned, because again, it doesn't have a public IP. Assigned, it's going to change over time. Every time you restart the machine, and in fact, it might actually change just like that. That makes it nigh on impossible to set up a firewall on this service, on the storage account, to make sure that it is only traffic from that specific machine that comes to this storage account or virtual network. Because you won't ever know which IP that specific virtual machine will have at any given time. Fine, you can dive into the portal and check which IP it has, and then manually put that into a firewall on the storage account. But come on, it's 2021. We don't do it that way. My friend was gaping. You can't be serious, he said. Does that mean that anyone with the right credentials can access my database as well? I mean, it's the same for the database service, right? Yeah, sure. Azure SQL Server is a platform as a service just like any other. But close your mouth a bit and think about it. It's not necessarily a bad thing. You might want your service to be accessible from the internet. And in the case of Azure SQL Server, it actually comes with its own built-in firewall. The Azure SQL Server is a database as a service, and as such, you don't need to think about stuff like patching, backups, and the like. However, just like we can have a philosophical discussion on serverless, and why as soon as you put serverless in front of something, it means that you have a heck of a lot more servers. It's just that you're not touching it. And it's the same thing with this database as a service. There is actually a database server underneath. And yes, you can set some settings on it. Especially important because it will influence the networking. The server is going to be put in a virtual network and other things. So you see, there's not just one, but two levels of firewalls in play. There's the server level firewall that restricts traffic to the server itself. And then there is the database level firewall. They behave pretty much identically. In fact, they're extremely similar to the network security groups that we looked at previously. So this is what it looks like, and it's not unlike logins and users in SQL Server. Word of warning though, the managed instance, which is not part of this session, does not behave like this, nor does the Azure Synapse Analytics. For the moment, I've been told that Microsoft is looking at unifying the whole shebang, making networking security behave in the same way, but we'll see when that comes into play. So with the database firewall, you can restrict access to your database service to a specific IP range, for instance. Do note that, again, that IP range must be static, must be known, the address of whatever is trying to reach the database. The Azure assigned IPs, well, while they will work, but you're stuck on updating this all the time. So how does this look? Well, let's take a peek inside of the portal again and see at the SQL Server. It was here somewhere. There we go. I don't have any access to this. There's nothing, basically nothing on this earth that can access this database because I don't have a rule that says come on in. My client IP address, and this is the IP address that my home router has. I can add that. Oops. And of course, I can't do two things at the same time. So trying to speak and write at the same time is bound to be a horrible experience. But here I can set a workstation rule. And that's pretty much what I need to do. And boom, now I can access this virtual, SQL Server through my workstation because I have this rule set. So what if you don't want to create a public IP and get the associated endpoint that goes with it? What if you'd like to add the private IPs of my virtual machines inside of my resource group to the firewall? And while you're at it, disabling public access to this thing at all. Let's talk about service endpoints. The service endpoint is a fairly new phenomenon, together with its cousin that we're going to be looking at in a second. The service endpoints, they provide a way to lock down access to platform as a service resources to a specific virtual network. However, you're still accessing the public endpoint. It's just locked down to specific traffics. And with service endpoints, you're also locking down access to the service and not a specific resource. So how does this work? Well, we're basically bringing the virtual network to the service, i.e. you're teaching the service, Azure SQL Server or storage accounts or whatever, to recognize and work with the internal traffic that originates from the virtual network. So if we have a private network that's 10.0.0 something, that's not going to be routable to the internet, but we can use that to add to the firewall of SQL Server or storage accounts, as long as we have set up the service endpoints. And this means also that we suddenly made it a lot more difficult to exfiltrate data because I can no longer access this storage account or the SQL Server from anywhere outside of my specific virtual network. That is kind of neat. Another advantage of doing it this way is that traffic will be routed to the Azure resources in an optimal way. There is what's known as user-defined routes. Say, for instance, that you have an overzealous networking group at your company. They have demanded that all the traffic that goes to the internet needs to go through some kind of appliance back home. Yeah, fine. But imagine what would happen if you're talking to a resource in Azure, a virtual machine that needs to talk to an Azure SQL Server, which is a service. What do you think is going to happen? Well, that is technically internet traffic because it is talking to the public endpoint. So the traffic goes through the VPN down into your network appliance and up through the VPN and back out to the internet. That is anything but efficient. With service endpoints, that's not going to happen because the traffic will automatically go straight to the service, but not over the internet. It will always be routed through the Microsoft backbone. So that is a very nice feature to have in this case. You set this up on the VNet, the virtual network, or the subnet. This is not set up on the specific resource. I'm going to show you how. So we are now back in the portal again. We're going to see on the virtual network, where did it go? There it is. And I can go for settings over here to the left. And there we have service endpoints. And how do we do this? We click on it. We're going to add a service endpoint. In this case, we're going to go for the SQL Server, the SQL Server's endpoint. And I want to put this into the database subnet. And there we go. We have now created a service endpoint inside of the subnet, the SQL database subnet in this specific VNet. So now the SQL Server will be able to understand the internal IPs from that specific network. That's kind of neat. Kind of neat. So we brought the virtual network to the service with these service endpoints. What if we could do it the other way around? What if we could get the service into the virtual network? Kind of the way we thought things would actually work when we started this whole journey. Oh yeah. Enter private link. The private link is even newer than the service endpoints. And this is available for select platform as a services. And it basically allows you to create a private endpoint in your virtual network. What does this mean? What it means that your private endpoint provides an internal IP address for your platform as a service. So instead of talking to your Azure SQL Server or your storage account or Cosmos DB or whatever through the public endpoint, you're now going to be talking to it through a private endpoint, thus the private link. It means that it's going to give you several benefits. The first one is, of course, you're going to be using a private IP. You're never going to touch the internet. Nothing is ever going to be available through the internet, period. This means that another useful thing is that we can do this over VPNs if you want to. We can use this over ExpressRoute, which is something I'm not going to be talking about. The access for this private link is now restricted solely to a specific resource. It's no longer, as I said, with the service endpoint, which I set on the subnet. This is a specific resource, a specific database, or a specific storage account. So you have complete control of data egress. And of course, you can create public endpoints between regions. So you're not stuck to just doing something in North Europe or West Europe, for instance. This is what it looks like. Traffic between your virtual network and the service travels over the Microsoft backbone. And exposing your service to the public internet is no longer necessary because we're just talking between the private networks. You can create your own private link service in your virtual network and deliver it to your customers if you so like. So the only thing is this, just like the service endpoints, it costs money. Nothing in life is free, especially not in Azure. But when you look at what it brings to the table and this might be the last piece of the puzzle for a secure, scalable solution, well, it's a no-brainer. I love the private link. This is updated almost daily. So when it started, it had a small subset of available resources. Now it is growing again just about every day. So I'm pretty sure that we'll have private links for just about every service in short order. The service endpoints, we set those up on the virtual network layer. The private link is set on the service instead, and even more specifically, the resource. I'm going to show you that on the SQL Server. So we're still here. We're on the SQL Server. Come on, SQL database. Not going to find it on the SQL database, but I'm going to find it on the SQL Server. Security, private endpoint connections. I can now bind this specific database server through a private endpoint. And I can't spell. To a specific resource type. Again, it's a SQL server. I have the DBAS RV, which is the database server, and also the sub-resource, which is SQL Server. I can connect this to a specific virtual network, and in this case, I don't have any networks in that specific subscription. So I'm not going to be able to connect it, unfortunately. But this is where my virtual network would be showing up. And that's pretty much it to create this private link. I have too many cables. There we go. Much better. So let's look at the picture we started with. Suddenly we have a somewhat better idea of what we've got going on. There are several things in here that we have yet to talk about, which is not going to be covered because this is, again, a 101. But we have been able to look at a few of these. Take, for instance, the NSGs, the network security gateways. They're designed to filter traffic. Behaves a bit like a stupid firewall. We've looked at the load balancers. The load balancer is designed to route incoming traffic to outgoing pools behind it. It's a way to expose a public IP to the internet, but not necessarily expose the backend virtual machines with their IPs. And of course, we also talked about the storage accounts and more specifically the service. What happens with the services? How do you access the services? What is the relationship between a virtual network and the services? And how does it work with billing and that kind of stuff? And of course, we had a conversation about the public IP. What is a public IP and when does it come into play? What's the difference between a private IP, a public IP, and a public endpoint? Those are not necessarily the same thing, and they can really do a number on you if you don't see the difference here. But again, as I said, there is so much more to cover. I mean, there are so many bits and pieces to go, and this is just a subset. I've only scratched the surface of what you can do with networking in Azure. And if you feel like this, fine. What you got here today is more than enough to get you started to look at networking as a database person. If you figure the things that I've covered here today out and you remember them and you apply them, you're well ahead of the pack in my view. There's so many times that I've had customers come in starting to work with Azure in SQL Server in Azure and be completely stumped over fairly basic networking things. Sure, they knew about IPs and they've heard about this firewall thing, But when it comes to the concept of subnetting or load balancers or anything like that, they were completely, they had no idea. So don't be that person. Use the information you have and go figure what you can do. So in summary, we can conclude that I don't need to know networking. It doesn't apply anymore. I'm sorry. It sucks to be you, but you need to know networking. You need to know basic networking. That's just the way it is. Because understanding the networking is absolute key. As a DBA, I am tasked with a few things. I'm tasked with making sure that my database is available, but I'm also tasked with making sure that my data stays secure. I don't want to leak data all over the place. It is messy. It is bad practice. And with GDPR, it can also turn into a very expensive experience. And as you've seen, a badly configured network can be a dangerous thing. So understanding networking is absolute key. And while we're on the concept of security, keep in mind that private is not necessarily so. You need to understand what private means. You need to understand what the use of this service mean. More than once, I've had a conversation with a security person at a on-prem company that has not worked with Azure previously, and they basically have a heart attack as soon as we start to talk about the services, and they go, no, you cannot use this. There's no way that you'll ever be allowed to do this over the internet. So using this information, you can hopefully calm them down a bit. So as I said, networking used to be outside of the scope of practice for DBA. But as more and more workloads move to the cloud, this is no longer the case. In order to stay relevant and in order to stay secure, you need to constantly update your skills. Networking skills, as we've seen in this hour, you're absolutely key. Take these new skills and these new insights and apply them to your environment, and never, ever stop learning. I might even see some of you back here for Networking 102. I'd love that. My name is Alexander, and I thank you so much for your time. Oh, a golf clap. Thank you.
Thank you very much. Entertaining and fun as always. We do have a question from the, well, actually we have two questions from the audience.
Oh dear.
Technically even three, but for one I need a little more clarity. So do I really have to be a networking expert as well these days? I only want to be a data engineer or a DBA. Discuss. You may guess where this came from.
So
really make me face.
I'm going to go ahead and say no, you don't need to be an expert, but you definitely need to know something. If nothing else, you need to know the basics so you can ask the questions and also help find the answers to questions that come in. Because again, you as a DBA, you're tasked with a few very specific things. One being security. You need to make sure that your data does not leak, and networking is absolute key.
Good answer. The other question that Billy McBeardface was raising is troubleshooting issues hard for all of this?
That is a
and maybe if I may
question.
add to that, is there anything that actually supports me in doing that, or is it more like, well, okay, it's not working. It might be the routing, it might be the VLAN, it might be the firewall, it might be the NSG, it might be the load balancer, it might be that I actually shut down my virtual machine, and that's why I can't connect to it. Is there anything that helps me with that?
So that is a fantastic question, and thank you, Rob, for that, because there are really good troubleshooting tools inside of Azure up to a specific point, I should say. If you're used to working with networking, and one of my deep dark secret is that I actually have a Cisco Certified Networking Associate certification back from the late 1800s. So
nobody likes show-offs, you know.
Yeah, right. So I know networking fairly well. And what I found is that if you know networking, there are pretty useful tools inside of the Azure portal. if you're coming from the SQL Server point of view, the tools are scary. They're definitely geared toward network. But as long as you're not trying to figure out why this SQL Server is behaving a specific way, we can troubleshoot the networking aspects fairly, I shouldn't say easily, but fairly comprehensively. But when it comes to why the SQL Server behaves in a specific network, that's a whole different kettle of fish. Then we do not have the same tool set, so to speak. That's when you need to change your perspective to look at it from the database point of view. So there are tools, yes, but not all the way for a DBA, and definitely not for a DBA to start with.
Okay, I love that question from Chris, so I'm going to take that first. It's not specifically presentation related. I'm going to go on a limb here and say it's not session related at all.
And I'm going to
like the
say
Lego
yes.
Iron Man mosaic on my screen. Is that a Lego Saturn V on your screen?
Yes, it is. It is indeed.
It actually
it was a
sits
lot
in
of
my
fun.
kitchen because I've reorganized my whole Legoland here by themes.
Oh, really?
So yeah, we may get to that after the next question. Then I can basically tell you where I put everything. But there's a great question by Yanchi. I hope I'm saying that right. I apologize in advance for every single name I'm going to pronounce wrong all day. And I like that question because I'm curious at your angle at this. So how can you make SQL servers talk to each other across regions, so make them able to join a failover cluster when they're placed in different but paired regions?
So that is also a good question. And I'm going to go with a multi-subnet failover clusters. So Ben looks confused.
No. The question for me would be, why would I even jump through that hoop and not just set up my SQL Server from the beginning from an Azure native way to be multi-region, and therefore say, hey, I know that this still causes the same issues, but that way Azure will take care of all of this for me.
Yeah. I think depending on where the question comes from, is it someone that did not set their environment up in a best practice way? Well, then you're going to have to bring out your duct tape basically to try to make it work. Or you do like Ben said, set it up the right way from the get-go, so it is aware that it is multi-region. Then it also depends on, do you really need to use SQL Server on a VM for this? Or would you be happy to use Azure SQL Server as a service? Because in that case, it's literally just 2 or 3 clicks and you're off to the races. So there are so many ways to solve the same issue. And again, with the enough force, you can make basically anything fit together.
And yeah, and this is kind of where I was going with my slightly confused look, because in so many instances I ran into basically exactly that, not exactly that SQL issue, but at some point I was like, hey, this is way too complicated. And as a general rule of thumb, I kind of learned in Azure, if it seems way too complicated, most probably I did it not necessarily wrong, but I could have done it, I could have gotten there easier, if that's a fair comment.
That
Not
is
always, and especially
that
not
is
for new
such an
features.
important point. And I find that, as I said, there are a couple of ways of doing sessions and teaching. If you're looking at concepts, then you're trying to explain things so you know what questions to ask. And I found the hard way so many times when I'm approaching a new subject that I don't know very much about, and I'm starting to ask questions, and I'm getting either very, very few answers, strange answers, or I can't find an answer. In many cases, I'm asking the wrong questions. And when I figure out the questions to ask, well, then it turns out that the community has done all the hard work again, and I could just benefit from that.